This is the ground where the space shuttle is flying. Okay. The circumference of that line, circular, is the astronaut. And if you do some calculations about gravity, then you would find that at this altitude, the gravitational acceleration is 91.8%. At this altitude, it's 91.8%. So, if you would have the tower, which is 280 kilometers high, and you would stand there, and if you would weigh, say, 100 pounds here, you would weigh 91.8 pounds there. So it's not true that the gravity is down to zero at this altitude. Matter of fact, let me show you where the moon is. And the moon is held in its orbit by the gravity of the Earth. This is the moon. And on the same scale as the Earth, the room is not quite big enough. This is 20 meters, and you would need 1 more meter, so a little more. There's the moon, and the moon is held in its orbit by the gravity of the Earth. So, of course, we see all these pictures of the astronauts being weightless. They seem to be weightless, but they are weightless for the wrong reasons. Yeah. I'll probably drop it. I'm not used to the microphone. Yeah, I can't keep talking. So, let's look at the history of gravity. And I have to take you back to Aristotle. Gravity is the first. Aristotle, great Greek philosopher, who lived from 384 to 322. 384 to 322 BC. Aristotle was thinking about many, many things, and he had a system figured out of the universe, and it was not his idea. He borrowed it from somebody else, but he adopted it, and it was the so-called two-sphere universe. The two-sphere universe is basically one large sphere on which the fixed stars are attached. And then in the middle of the universe we have the Earth, and the moon goes around the Earth, and everything else moves around the Earth. And idea was that everything beneath the moon was earthly, imperfect, changing, and everything above the moon, outwards, was heavenly, never changing, and perfect. And the idea of these Greek philosophers about matter was that there are four elements, and the elements are earth, water, fire, and air. This idea Aristotle also borrowed from somebody, but he used it, and since he was the great authority, when he said something, then it was, as he said it. And he had a very simple explanation for an object to fall down. He said, earth is in the middle, and then next comes water, and then comes air, and then comes fire. And everything has its natural place. So if we take an object which is earth-like, something like this, it'll fall down because its natural place is down. If we have a gas, say a gas in water, it'll bubble and rise because its natural place is up. And fire also, natural place is up, it rises up. So that's Aristotle didn't do much experimentation. The Greek philosophers, not all of them, but most of them, preferred to think about things and not do experiments. Also, they didn't have the equipment, but that wouldn't be a good enough reason not to do experiments. But they were arguing from first principles, and then they were logic. A circle is perfect, and everything in the heavens has to be perfect, and the most perfect curve is a circle, or the most perfect three-dimensional shape is a sphere. So all the stars would move on spheres. As a matter of fact, the philosophers believed that these were not just fictitious spheres, not all of them. I shouldn't say all of them, because there are always some who had other ideas, but most of them believed that these were crystal spheres, that the stars were actually physically attached to a sphere which would turn. And there were spheres in spheres turning. And they would make music, and we call that the music of the spheres. They thought they would really make music. And then when you look closely, there were a few things which didn't really work. For example, there are some planets which appear to move in one direction and then stop and turn around and go in the other direction, and stop again and turn around and go forward. That's called retrograde motion. Mars, for example, is doing that. There are some planets which do that, and that can't really be explained with perfect spheres. But well, they just try to ignore those things. Also, some planets really vary in brightness. The brightness of planets varies. We now know that it comes because they are at different distances to us, so their brightness changes. That's also a thing which didn't fit into the picture, but it was well, they disregarded that. Well, there was another philosopher, Aristotle. And Aristarchus then there is a right angle if you connect the Earth and the Moon and the Sun. The Sun shines on the Moon and only you see only half of it. There must be a right angle from the Earth to the Moon to the Sun. When you, at that point, measure the angle between the Earth and the Sun, then you have a triangle in which you know two angles, and you can figure out the relative distances from the Earth to the Moon and from the Moon to the Sun, or from the Earth to the Sun. Did this, and he found out that the Sun is much bigger than the Earth, because he found out that it's much further away from the Moon than from the Earth. No, let's rephrase that. He found that the distance between the Earth and the Sun is much bigger than the distance between the Earth and the Moon. And since the Earth and the Moon and the Sun appear to be the same size, he argued, since the Sun is so much further away, it must be so much bigger. If the Sun is 20 times as far away than the Moon, it must, and looks the same, it must be 20 times bigger than the Moon. His numbers were not correct because to measure this angle is quite a task, and a little error in that angle makes a large difference in the distances. So his numbers came out wrong, but nevertheless, he figured out that the Sun is much bigger than the Earth and the Moon, and he argued, why should a large object circle a little one? It must be the other way around. So he argued that all planets, including the Earth, move around the Sun, and the Sun would be the center. That was 280 BC. It wasn't very popular at that time, and Aristotle's books were forgotten, and it wasn't until